Hello, people. This is lecture number 2 for midterm 1 material, and we are gonna go into the second technique of integration, trigonometric integrals. These are really easy to accomplish or finish once you get a little bit of practice in. Unlike the others, it's usually rinse and repeat. Is just you do the same thing over and over again. So here it says we've dealt with the integrating trig functions before, like this, where you can, this is a simple u sub. Usually you want your u to be the highest power, because if you can make this become u to the 8, then you integrate u to the 8, you just get u to the 9 over 9, which is pretty easy. But making cosine as u, that's just one power, and then now you'll have to deal with these 8 powers, which is kind of annoying. So that's why we just set this to sine, because the higher power. And that's like the great hint to take. As soon as you see a higher power, that's most likely your u. And so when we derive this, we just get our cos x dx. And as you can see, this overtakes these two things. And this is just the integral. Sine becomes my u, so that's u to the 8. And my du takes over these two, so it just becomes du. And that just becomes, 9u over 9 plus c, and then you replace your u with your sine, so it becomes sine 9x over 9 plus c. But now what happens if you get something like this? You can't really u sub this, because as we can see up here, if we were to use the same method we used here, right, what will happen is that this cos, I don't know why this is stuck. Okay, this cos will not be fully covered by this, and that's a problem that you can't really deal with when it comes to u sub. So what can you do? This is where you need to know a little bit of trig identities, but it's like 3 trig identities that you need to know, and I believe they're given. So if you memorize them, it is better, because it'll make you solve things faster. To save some time on exams, but if you don't, it's fine. So this is one equation. The other equations we'll go over in a bit, but this one, you can basically replace a couple things in terms of sine or cos. So if I take sine to one side, I can replace a cos squared by 1 minus sine squared. And I could do this vice versa. If I take cos to the other side, then I can cover a sine squared using 1 minus cos. This is how you can change sine in terms of cos, and that's how you can change cos in terms of sine. And that will really help you out. It'll come in handy. So you see, if I use the same technique I use here, you know how I said this is the highest power? So I'm going to set it to u, because I want to deal with the highest power using u, because that's the easiest to integrate. You see, I'm going to integrate now. I'm going to use my sine as my u, so that's u8. Then I'm going to take cos, so you see how this takes 1 cos? So I'm going to take over 1 cos using my du, and that's going to be du. What I'll have left is 2 more coses, right? So I'll have 2 cos squared. And, well, I don't have the dx anymore, because it got replaced by my du. Right? How can I get rid of this in terms of u? Because I have my u as sine. So can I turn this into sine and then turn my sine into u? And you can do that using this right here. It says cos squared, so I'm going to make this over here equal the equation, right? And so I'm going to integrate. I'll have u to the 8, same thing, except my cos now becomes 1 minus sine squared x. Now I said my u equals sine, so I can just replace this in terms of u, which will really make your life a lot easier. 1 minus u squared. Now if I just rearrange this, I'll get u to the 8, 1 minus u squared du. And I can FOIL. So I'll get u to the 8 minus u to the 10 du. And you can, from here on out, you can just integrate separately, like the integral of u to the 8 minus the integral u to the 10 du, right? And then once you do this whole operation, we'll get u to the 9 over 9 minus u, well, yeah, 8 plus 1, and this will be 11 to the 11. And don't forget your last step, or your last two steps, is replace your u with what it was originally. That's sine 9 to the x over 9 minus sine 11 x over 11, and your plus c, which is your second step. Now you can face a little bit weirder situations with this, but they're all mostly the same thing. So when it comes to this, what do you put your u as? Now I did say you want to put your u as the highest power, but if you have a higher power, but also you have a weird looking integral like that square root of cos, then you'll want to set your square root to u, whatever under my square root, because I can't really square root cos integral. I can't integrate that, right? So as soon as you see something weird that you can't integrate, that's most likely your u. That is the easiest way to see it. Up here, she probably on the lecture explains like, oh, if your sine is even and your cos is this, do that. And if your sine is odd and your cos is even, I don't like memorizing stuff. I like to use more common sense. So if you see something weird, that's most likely your u. And so that's what we're going to do here. That cos looks weird, so I'm going to set it as my u. So my du becomes sine x, right? And so now what I'm going to do, I get the integral of sine to the 4 co x times the root u, because that gets replaced with my cos. And the reason this is 4 not 5 is because this du will take one cos with it. All right? And so now what can I do to sine? I can use so sine squared x plus cos squared x equals 1. Take my cos to the other side. How do you know when to do this? The way you know when to do this is because your u is set to cos, then you know you have to put this in terms of cos. And so since my sine squared, this is the same thing as writing sine squared x to the power of 2. This is the same thing. All right? And so what I'm going to do here is set this to 1 minus cos 2x. And you see this is where it comes from. All squared because of this square, right? And this is this comes from the sine. And now I still have my root u du. Now I did say my u is cos, so let's replace that. 1 minus u squared root u du. Right, now let's apply the squared in. I will get 1. Trying to remember, is this with this term plus when I apply my root? If I remember correctly, the way you would expand this is your root would become 1 minus u squared times 1 minus u squared, because it's quadratic. You don't just apply the 2 on your 1 and apply the 2 on your u, because you have to do this, then you have to FOIL. And this is u. I don't know why I wrote it like that. Alright, and now when we FOIL, we'll get 1. And then 1 times u, which is minus u squared, minus times 1, minus u squared again, and times this, you get plus u to the 4. And we still have our square root u du. Now if we keep going, this becomes integral of 1 minus 2 u2. I'm just simplifying here, nothing too special. And now what I can go from this is I can multiply this in. This is the same thing as saying u 1 over 2. All right, it's the same thing. So now when I multiply this in, I will get the integral. U 1 over 2 times u to the 4 is u to the 2 minus u to the 1. So half times 2 is just 1. So what I'll get is 2 u to the 1/2. Or, sorry, that would be 1. And then minus, this is plus, this is minus, and then this is positive. So it would be plus my u to the 1/2. Make sense? now you can really integrate this pretty easily. So, because you can split this into a couple parts. You could split this into, you know, your integral of u squared minus your integral of u of 2u minus, or plus, sorry, your integral of u 1/2 du. Oops. And so when you integrate this, you'll just get 3u over 3 the 2u to the power 2 divided by 2 plus this one would become 1/2 plus 1 is 3 over 2. This is u, 3 over 2. And then you divide it by 3 over 2, but you can remember that when you divide, you always can flip and multiply. So this is the same thing as saying this exponent 3 to 3 minus this 2 and this 2 cancel out, becoming 1, so this is u squared plus 2 times u 3 over 2 all divided by 3. It's a cleaner way to write it. This is not technically wrong, but if you do write this, I bet you whoever's marking your paper is gonna be like, no way this person did this. So they'll probably think you're retarded, so you should probably do this instead. Anyways, all right, now we have cos cubed sine 11. What can you do in this scenario? Because remember how I said whenever you have something looking weird, set that to your u and or your highest power. So right now I don't see anything weird, but I do have a higher power. So u equals my sine, and then my du equals cos. Now plug this in. Your cos will get split off, so you'll get cos x. This will be replaced by your du, right? That will go away. That means we'll have cos squared left. And then my u is going to be sine. My sine is going to be u. So I'm going to have u11 and du. That takes care of my 1 cos and my dx. Now what can I do here? Same thing. We'll do is your cos squared x equals sine squared x negative plus 1. Or if I rewrite this, 1 minus sine squared x. Now if I replace this, what I'll have is 1 minus sine squared x u11. And I said my u equals my sine, so 1 minus u squared, because of this squared right here, u11 du, and you can just FOIL. And from here on out, I'm pretty sure you guys can integrate this, so I'm going to leave it. Now, what happens if you have sine squared on its own? We don't have a, what do you say? Like, you know how we had this to replace your cos squared x? But when you have sine squared, you can replace it technically with 1 minus cos squared x. That's probably what you're going to think of doing maybe. But if you do, you still have to integrate your cos squared. How can you integrate that? Are you going to turn it back to 1 minus sine squared? But this is, you're just looping around in a circle, so you can't really do this. And that is where we introduced half angle formulas. You can set this to your u, right? Say u equals my sine x, but then I'll have my du equals cos x dx. I don't have a cos x to replace with my du, so that won't work either. So what you can use is these half angle formulas, and because you see a check mark here, these are given. So you have bounds. I'm not going to really do bounds because you guys probably know how to apply bounds. Okay, so what does this look like? Does it look like this? Does it look like this? All right, you're not an AI, so you should probably know that it looks like that. So now I can integrate 1 over 2. I'm just replacing it. That's all I'm doing here. dx. All right, now where can you go from here? You can FOIL. That's one way to do it. Or you can just take out that 1/2 out. So I can say 1/2 integral 1 minus cos 2x dx, right? Now I can apply, so integral of 1 minus the integral of cos x dx. And you see now when I do this, this is a simple 1/2 times the integral of this is x minus the integral of this is sine x. and my dx goes away. Right, and that is what I get. And after this, you can apply your bounds, which is from 0 to 1/2. And don't forget your, well, we have bounds here, so we don't have a plus c. But that's about it for this. Oh, I did forget one part, my 2 here. So when you integrate cos of 2x, you want to divide by the inside. You want to divide by the derivative of the inside. So I can fix my mistake here real quick. So you see when I go from here, I get 1/2. And then my 1 becomes x minus. When I integrate my cos, it becomes sine 2x. It stays. But then I have to divide by the integral of this. The integral of 2x, you're not a retard, you would know it's 2. So that's about it. My dx goes away because this is a definite integral. Well, it should go away because I'm integrating, so that would be 0, 1/2. Dubs. Okay. Now we have some more weird looking things. What if they're both squared? What can you do? You can't really set my u to cos, right? And then if I have my du as sine dx, that's a horrible looking x. If I use this, I will get u squared du, and I'll have one sine left. What am I going to do with the sine? Can't really do much. So what you'll have to do is use half angle on both of them. Okay, so these are our formulas. We're going to replace our sine squared with this and our cos squared with this. You're like, oh, they look the same, except you have a negative here and you have a positive here. That's the only difference. And that is a good thing because it puts everything in cos as well, which is nice. So 1/2 times 1 minus cos squared x. Sorry, not squared. This would be 2x. And then that replaces my sine. And then this is going to replace my cos, which is 1/2 again. 1 plus cos 2x. Now what you'll do is you can FOIL. I can pull out a 1/2. This is the same thing. Right? And this 1/2 will come outside my integral. I'll have to FOIL these. Right? And I think you guys can take it away from here. Actually, I'll go further because there's a weird step in this. Just in case it confuses you a little bit. So I get 1/2 times the integral of, or I guess a better, cleaner way to do this is just the integral. Just don't forget that this is times. When I FOIL, I'll get 1 times 1, which is 1. Negative cos squared times 1, which is negative cos squared, or not squared, x, 2x. Then I'll have 1 times, so this is plus cos 2x, meaning these two cancel out. And then I'll get a negative cos times this is, what I'll get is negative cos 2x squared. And what this simplifies to really is 1/2, 1 minus cos squared 2x. And so now we went from having 2 squared trigs to 1 squared trig. And this is a good thing. It means you're on the right path. It's getting easier. You just have to do half angle one more time. And this is where the weird step comes into play. So we'll have 1/2 integral of 1 stays minus. This whole thing will get replaced by my cos identity, which is 1/2 1 plus cos. Now, what do you put as your x here? What you'll do is, if you remember, the thing is, for this step, it's such a trivial step, it would be better to remember it because the logic doesn't really help you. But just to explain the logic behind it, I'll do in blue here on the side. Cos 2x equals 1/2 1 plus cos, right? And that's our identity that we've been using from the half angle. It's a given formula. if I have cos squared with 2x this time, as you can see, x turns into 2x. It doubled. So what I can do is 1 plus, because I have 2 here, that means my cos is 4x. Okay? And so if you have 3, it'll become 6. If you have 9, it'll become 18, and so on. Okay? So it just doubles, don't forget. So if you don't really need to understand the logic, I shall keep it, just in case you want to look at it. Okay, so what happens here is because we have 2, it becomes 4x. Now I'll just simply FOIL. So what I'll get is 1/2 integral 1 minus 1/2 times 1 is 1/2 plus 1/2 cos. Alright, now I can FOIL in my negative. And so this will become 1 minus 1/2, which is 1/2. Then the negative will apply to this, which becomes negative. I just went a step ahead here, so I'm going to actually go back a step in case you guys get confused on this part. So minus 1/2 minus 1/2 cos 4x. Now what I'll do is combine these two. So I'll get okay, and I can pull out the 2 halves right here. Okay, so I'll just get, or you can, to be honest, you can even integrate this as is, however you feel comfortable. I don't think I'm going to go past this step because I'm pretty sure you guys are fine from here. You can integrate your cos as your sine, 4x, and don't forget, when you integrate this, you have to divide by whatever is the integral of the inside, which is 4. Alright, so moving on to the next step. Now what happens when we want to integrate tan, secant, cosecant? Same thing. Same exact thing. It's just you have different. So the other one we have is cos squared x plus sine squared x equals 1. When you rearrange for one or the other, you get 1 minus cos x or cos 2x, or 1 minus sine, right, when you isolate. For here, it's not a minus, but it's a plus. That's the only difference. Same logic, same exact logic. So here saying if you have an even powered secant, do this. If you have an n powered tan, do this. But like I said, I don't think you guys should memorize sentences. So what I'll say is think it through. If you practice this, you like it will be second nature to you. But if you don't, just set your u to the weird one. All right. So you see here, if I set u to tan, all right, then what my du is, for this one, you don't apply it to the higher power, by the way. Now, the higher power rule is just for sinus cos. You make q your highest power, or the weird one. Here, that's not the case, because when I derive my tan, I get secant squared x dx. And you see, if I replace this, what I'll get is u squared, and my secant will get replaced by my du. Then I'll have an extra secant squared left. And now it's the same thing with our cos and tan strategy. We have 1 plus tan squared x equals secant squared x. And now I can replace this with tan, and this will become 1 plus tan squared x, right? And the du stays, and the u squared stays, the integral. My u is tan x, and you just go on from here. You get u squared, and then you'll get 1 plus u squared again, because it's my tan. Du, FOIL, integrate. Now the question is, well, what if you were a little bit, what if you went into the exam fried, and you set your u to secant instead? My integral, my derivative of secant, is tan x secant x dx. You don't really have to memorize the integral. I'm pretty sure the derivative of secant is given, but I'm just a weird guy, so I memorize them. Anyways, so when you replace this shit in, you'll get an integral of, so my secant, I'll get u4 because I replaced it, but my tan secant I can't really replace this with my du because my du needs a secant. So what I'll do is I'm only going to take 1. I'm only going to take 3 from my secant. I'm going to leave 1 behind. And that one will get replaced. So we'll have secant x and, oops. So I'll get tan squared x dx left. And then if I replace it, I'll get u cubed du. But I'll also get a tan left here. And that is a problem. Because you can't really replace your tan. My u is secant. And so this is where you just want to look ahead. Like, set your u to something, either one or the other. Get your du, and then just look at it. Before you go throughout the whole integral and write out like this. Like, if I replace my du, what will I have left? If what you have left, you can convert in terms of tan, or in terms of whatever your u is, and go ahead. But if you just by looking at it, you're like, wait, I'm gonna have something that I can't convert to the value of u, and I can't really replace with u, then I can't set my u to that because I would run into this problem. And so here we have a summary. Powers of tan split off. Even if you're good at memorizing, sure, memorize this. But I know some people black out on the exams and midterms sometimes. Your memory doesn't work. But your logic will always work on midterms, doesn't matter. Logic is logic. So that's why I would say understand the logic first. Integrating this, tan, so our rule was 1 plus tan squared. Just in case you don't have your formula sheet beside you. And 1 plus secant squared x equals tan squared x. So you see my tan and secant are related to each other. But my sine and tan are related, but they're not related in these terms. We do know that your tan x equals sine x over cos x. Or your opposite over adjacent. That's tan, right? And so since I have tan squared, I can just replace it with this. You don't really have to do this. I don't think she brings on the exam that often. But in case she fucks us over, it's pretty simple. You just replace it like this. Now what you'll get is sine cubed x. If I do 1 over cos squared, I can replace this with a simple cos x to the power of -2. And remember how we said set whatever's weird to you when it comes to sine and cos. Now this is a higher power. This is a -2 exponent, which is weird. So I don't like weird things. So I'm gonna make them my cos x. Okay? And then my du is, pretty sure this is negative sign. This got me on one of the midterms. I forgot my negative. And they took 0.5 of a mark away. Say sine x dx. And so what I can do here, just replace stuff. I'll just take my negative out. And so I'll get my cos becomes u to the -2. My sine, one of them goes away to my du, right? I'll have one more sine left. And from here, you guys know what to do. We have the sine squared x equals 1 minus cos squared x, right? And then from here on out, you can, this is it too, right? From here on out, you can replace it, expand, FOIL, integrate. Now we're coming to the next ones, and this is tan secant. This is just, I don't think I'm going to go through these. I think you guys should practice these. And it's using the same identities we've been using. It's just, for this one, you see, my tan is alone. So if I set it to u, I do equals tan x, du equals secant squared x. Before I follow with anything, my u becomes my tan, my secant becomes my du, and I'll have one secant left. That's not good. You see, before it takes me 5 seconds. You just look at it. I have u, secant, I have a secant left. That doesn't work. Try again, right? And so now I'll say, you know what? Then my u will become my secant. What's my du? Like I said, this is given. So it'd be tan x secant x dx. And you see, well, okay, nice. Tan secant will replace tan secant, but I'll have a 2 left behind. And then that will take on my u. Okay? So I'll have secant. So, well, not secant, I'll have u of this squared left. Then my tan secant will get replaced by du. And look how easy this looks. All right, this is a very short one. Also, don't forget your plus c's when you're done integrating. This is a cotangent cosecant. We've done the same thing with secant cosecant, or secant tan, and your sine cos. Like I said, it's mostly rinse and repeat. You set something to u and you change the identity. So, what can we set to u here? Let's start with the higher power. Cosecant. Cosecant x. The derivative of your cosecant x, if I can remember this properly, I believe it is negative cotangent cosecant. X. Is it given? Let's see. Yeah, dude, I don't make mistakes. Unfortunate for you guys. Yeah, so that's you see now if I replace this, I'm gonna just think about it without writing the whole thing, because you know you want to save time. So my u, I have to leave one cosecant behind, so I'll have a u squared. And then my du will replace one of these, so I'll have to the power 3. Right, and it will take the second leftover one, my du. And I'm like, huh, I have a cosecant to the power 3 left. I can technically replace this with the identity. Right, your 1 plus, this one I don't remember, which is unfortunate. Oh, I actually got it right. That's funny. Okay, 1 plus co, so there you go. I can technically replace this, but I'll still have one cosecant left, and that's my u. So, see, that might actually work. But what will I have left? So my co, oh, see, I made a mistake here actually. So you see, this is actually the other way. My u is cosecant. So my u here will be 3, right? Because cosecant. And then my du will take one of this. So I'll have a co squared x. And it works this way as well. So I gotta change my identity for cotangent. I'll get co squared x equals 1 plus cosecant. They look so similar. So annoying. Alright. So let's sub stuff in. I'll take my negative out since I know it's coming anyway. My cotangent squared is 1 plus cosecant squared x. Cosecant u du. This would be 3. 1 plus, this is u, just replace it. Right? So u squared, u to the 3 du. And then from here you can integrate and solve the rest. Hope this helped. GG's.